All right, so here's an example of pulling everything together. Okay, so here's a graph of a polynomial, and we need to state the degree of the polynomial. That's kind of the whole goal, is to know the degree of the polynomial. And when we get into solving these, you'll see why it's important to know the degree. So let's first identify, just by looking at the graph, the number of turning points. So I see 1 and 2 and 3 and 4. So I got 4 turning points. Now let's identify the number of X intercepts. So I see 1, 2, 3, 4, 5. So I got 5 of those. You may already be able to make a guess as to what kind of degree this is. If I've got 4 turning points and if I've got 5 X intercepts. So go ahead and figure out what kind of degree that is. 1, 2, 3, 4, or 5. The end behavior might also help you if you're a little unclear. So I notice on the left-hand side, as x is approaching negative infinity, f of x approaches negative infinity. So the left-hand side end behavior is negative. The right-hand side, as f of x approaches positive infinity, f of x approaches positive infinity. This might also help solidify your guess as to what degree it is. I'm going to guess that this is degree 5 because it's got 4 turning points, 5 X intercepts, and it has end behavior where the left-hand side differs from the right-hand side. What about that leading coefficient? Can you tell? Is it positive or is it negative? Look at your chart, and if you see what is happening on the left side, see what's happening on the right side. If you think that is degree 5, can you tell if the leading coefficient is positive or negative? And I'm going to take a guess and say it's positive and see what you think about that one. So there's an example. I've given a graph. We look at the turning points, we look at the x-intercepts, we look at the end behavior, and we draw a conclusion as to what degree it is. So there's one type of example. Let's do another type. All right, so a new type of example is going to be given an equation. Come up with that. So here's an equation. X to the 4th minus 4x to the 3rd plus 3x squared minus 3. Don't graph it, just look at the equation. So based on the degree of the polynomial, that's the highest degree, can you tell how many turning points it's going to have? So if the degree is 4, we might have a maximum of 3. How about the x-intercepts? When you look at your chart, if we have a degree 4, we're going to have a maximum of 4 x-intercepts. How about the end behavior? Can you tell what the end behavior is? Well, the leading coefficient is positive, and it's a degree 4. So the end behavior is positive, positive. And I can tell all that just by looking at the equation. So that's kind of example 2. Given an equation, can you tell the number of turning points? Can you tell the x-intercepts? And can you tell the end behavior? So that's the end of this lesson.